Hello, and welcome to the MIT SDM Systems Thinking webinar series. My name is Naomi Gutierrez, Communications Administrator for SDM, and I am today's host. Today's speaker is Jayraj Nair, Technologist and Advisor to VMware. He has spent much of his career in leadership roles building products at companies like Intel and EMC. Over the last 5 years, he incubated new industrial IoT service business for Infosys and Wipro. Jayraj is a computer engineer by background and holds an MBA from ISU and a master's in engineering and management from MIT System Design and Management. His talk today is titled Realizing Business Outcomes and Scaling Industrial IoT. If you have questions for the presenter, please enter them into the chat window at the side of the video. They will be addressed during the Q&A portion of this session. The recording of this presentation will be available online after today's session. A link will be sent to all registrants. And with that, please take it away, Jayraj.
Good morning and good afternoon. Thank you, Naomi, for organizing the session. And my apologies for not making it person at the MIT campus because of coronavirus constraints, travel constraints. But thank you again and welcome everyone. What I will try to do in this session is basically talk about how to approach industrial IoT programs, talk about the technology elements, talk about the strategy and design aspects, as well as get into a little bit of detail about things to do from a systems thinking perspective. Let me get into it and start with what are some of the things we should consider when initiating any kind of industrial IoT program. In terms of the definition of industrial IoT, you can see a plethora of smart connected endpoints coming into operation. It is generating high volume, high velocity data that you can analyze and get some business impact and business outcome out of it. So typically as technologists, most of us who are either in engineering programs or have been in the industry for a while, really jump into it, start building solutions across any kind of technology ingredient we can lay our hands on. Ideally, a better approach to take is to step back, think about what is the underlying business problem that we are trying to solve, design it in a very iterative, better way of building solution that meets an end user's expectations, be it strategy expectations. I'll get into the specifics of what kind of strategies are playing out in the space, what type of design technologies you can implement, and the plethora of technology options we got. So operating at the intersection of these three elements, which is strategy, design, and technology, is imperative for success. What does a step back into the strategy zone mean? Frankly, most of the technology programs where I have been involved in, the easiest part seems to be building a technology stack. The tougher part is about articulating the use cases, understanding the business impact that one can make. All of this talk about digital transformation only gets meaningful if it generates certain sort of an ROI or a customer experience enhancement for the end user. So most of the strategy elements one should consider in terms of doing an industrial IoT program is the top line changes. Top line impact can be in terms of creating net new product to service transformation, implying you could actually now sell new services. You can start to monetize net new capabilities that you were not able to do before because now you have a plethora of operational data available to you. In terms of the bottom line impact, which is where a bulk of the programs gets initiated, most of the CFOs, CXOs want to improve 10, 20, 30% efficiencies into their operating environments. When you have a better view and visibility on how the equipment or the asset that you have is operating, you can definitely figure out ways to improve. So that operational efficiency dial helps you with the bottom line impact. So financially, most of these large scale programs that are being deployed have made significant efficiency gains for the end user. In terms of the user experience itself, if you look at ways in which the employees, the customer, the supplier interact with their operating environment, there is a significant new way of touching, experiencing. Take the example of a service lifecycle scenario. In the case of a service lifecycle scenario, now you're a technician who's going to do the maintenance on a particular endpoint, be it a moving asset of some kind, be it a truck or a jet engine, for example. The ability to get information ahead of time, figure out what parts need to be replaced, how the service steps need to be conducted. All of that is now helping enhance and find better ways of working. So if I take a few examples, let me kind of talk about operational efficiency use cases. If you have, I'll give you a few examples. One where there's a lot of medical diagnostic equipment scattered in a lot of hospitals around the world. And the operator and the owner of these equipment used to be these hospitals. But nowadays, when a remote services capability has been enabled through Industrial IoT, so you can actually tunnel in into the equipment, you can manage the equipment, you have a better view on how the machine is operating, you can predict failures, you can send a technician and take corrective before actually unplanned downtime happens. You can get some maintenance work done on it. Those kind of capabilities, bottom line, impact your efficiencies of operating that environment. There's another example where you have large industrial pumps operating in several utilities, especially around the distribution and consumption of energy. Now, those pumps, if they are exceeding their operating parameters, they're vibrating a lot, they're consuming a lot more energy. Those metrics are significant metrics on a timely basis if they are received by the maintenance crew, the maintenance technician. Your operating parameters are completely different. You interrupt, you take care of problems before they actually happen. So those kinds of approaches to improving our operational efficiencies has got a long payback. Let me get a little bit into the design aspects. When you look at the way these systems are designed, first of all, design is not just about human factors engineering and having a cool looking UI that makes us interact with the system more efficiently or in a much more satisfying manner. It is also about the design thinking approach. It's also about how do you iterate and do discovery-led processes. How do you interact in a very thought-through uh, manner which impacts the human experiences. Typically, technologists tend to modularize, build stacks together, me being one of them, in a very, what do you call, engineered, performance optimized, speeds and feeds kind of method. If you step back a little bit and look at how is this technology and this use case going to come together and how are these experiences going to be consumed, if you have the focus on the human being on the other side of the technology, it actually enhances desirability. When people like something, they mess with it, they use it, consumption is more. I'll give you a very simple example on this. Let's take the example of connected insurance use case. In that case, while a ton of feed from the vehicle is being collected and shared um, to the insurance provider and from the provider to the customer, some sort of a gamification engine, when it was added to the front end of it, enabled parents with the kids who are driving, 16-year-olds driving around, to enhance and kind of augment and behavior and kind of modulate the behavior of the kids in terms of driving. You get more points as you drive better, you get more better ways of interacting with the system. So the data collection and the exercise of actually monitoring and management of that experience changes significantly. In terms of simplification, it's very important that complexity of any kind, be it at a systemic level or even the sheer way layout on a UI UX is done, makes a significant impact in terms of its adoption of the technology. If it is simple, easy to use, people use it more. From a technology standpoint, this is, of course, something that I tend to lean on a lot more as a technologist. But in the industrial IoT space, you have a plethora of technology ingredients that come into the mix. You probably have looked at all the three-tiered architecture that was published by the Industrial Internet Consortium. You have the edge tier, the platform tier, and the enterprise tier, very simplistic approach. But you have multiple types of edge. I mean, if you look at three major technology ingredients, you have compute, network, and storage. A different combination of these capabilities appear at different tiers. So from an edge tier perspective, all the software that can ride atop different capabilities that are compute intensive, there is some degree of inference that can be done, some degree of training that can be done at the edge, some kind of processing can be done at the edge. It all depends on what the edge is constituting. It can have microcontroller based architectures. It can have more complex data center itself can be an edge. If you look at today's telco edges enabled at the aggregation points, they are nothing but small micro data centers in one way. In terms of connectivity, there's so many options in terms of the changes, the dramatic improvement in throughput, as well as lower latencies that is coming up with 5G. It is going to transform the way compute is enabled, and the communication capabilities with 5G, all in terms of network slicing and software-defined networks. All of these capabilities are enhancing the way the edge connects to the platform tier. Now, in terms of the platform tier capabilities, you have a plethora of options as well. You have the private cloud, you have the hybrid cloud, you have the public cloud, the telco cloud, you have the edge cloud. In all of these cloud-based infrastructures, you have now high volume, high velocity data coming through, and you can conduct analytics of various kinds, stream analytics, time series analytics. You can store, hot data, warm data, cold data in different places, contextualize them, correlate them. But at the end of the day, what you're trying to do is do some good insights with the data that you're collecting, and then operationalize that into some sort of an enterprise system that does service lifecycle management, inventory management, offer management, sales management, the cluster of the traditional enterprise applications, which are also transforming, by the way, as more cloud native apps. Those apps would ingest this high volume data and do something meaningful with it. So from a tiering of these technology elements, you have the edge tier where you have various degrees of compute, network, and storage available. Bulk of the analytics, insight, application of cloud services on AI, ML, all of that is happening in the platform tier. And then, of course, on the enterprise tier, you have the traditional enterprise apps completing the life cycle of the exercise that data can enable. So an end-to-end technology stack is relevant. And frankly, it is not just provided by one technology company. It is a heterogeneous mix of ingredients. I'll get into the ecosystem a little bit later, and you can see many people have to come together to make a solution successful. Before I get into the reference architecture of a stack, a long time ago, I think it's kind of reminiscence of the time that I spent on campus. We had to submit a thesis, and it was on user-driven product innovation that I had submitted, and a very simple approach. You have to focus on use cases, define the use cases. Use cases can be articulated in one way as the interaction between different stakeholders and the workflow and handoffs between different stakeholders in the process. Reference architecture can be thought of more about building blocks and how modular systems components can be stitched together and the interfaces between them, the types of event and data processing that is happening between them. And a stack is nothing but actual hardware and software stack that you stand up. Most often in these industrial IoT programs or any kind of software and systems engineering programs, you really don't have a full handle on any one of these three elements day one, right? You start, you pen down, put a stake in the ground, come up with a use case based on what the end user is expecting, work with them, create a reference architecture, and then stand up a prototype and kind of create an initial iteration of it. And then you keep going around in a very fast, agile, iterative, responsive way to stand up the ultimate endpoint result. But this whole traditional ways of working in terms of waterfall methodologies, I'll capture all the requirements, pen it all down, create an architecture and be done with it, and the stack be done with it. That approach never works. They used to work in a very different world about 3 decades ago, 2 decades ago when I was programming. We used to have complex requirements capture methods, but a significant shift in terms of CI/CD, DevOps methods of developing the agile ways of working, agile ways of developing software and systems has come to bear in this era. So typically in all of these programs, you would go about doing an assets assessment. In terms of penning down what you want the end solution to be, you do create a sense of direction and a vision of what you want to build. And then, transformation from an as-is to to-be has to have a roadmap, both a software roadmap, a systems roadmap, and a sense of time on when certain milestones and deliverables will be achieved. So an as-is assessment, a to-be plan, and a transformation plan has to accompany. And then you go into this continuous delivery, rapid prototyping method about creating ingredients and examples that can actually meet the expectations of the use case. So a very different way of working. Now, in terms of doing this work with customers, with partners, there's a lot of very interesting ways of going about it. I think you look at some of the new ways of working with these design shops. The workspace, the environment, the lighthouse, the beach house kind of projects, or the beachhead kind of projects. The framing of those programs and projects have evolved quite a bit. I think in a very simplistic way, the best method that works is where the right stakeholders are involved. They are together with you, working on building and developing a solution. So getting the right stakeholders and iterating and co-innovating together with the customer is the right approach to take. This is very different than the traditional ways that we were used to. But nowadays, agile ways of working produces better results on a faster time to market as well. Let me kind of step back a little before I get into certain technology stacks and reference architectures. I think if you start looking at us from a systems engineering perspective, I think in the MIT SDM, two of my favorite courses were around systems architecture. And there was actually a very interesting course around systems dynamics, where you kind of look at dependencies and how things, causal linkages between systems. You have different modules and components within a system, and then you have systems that reside within systems. So you create this ontology or a hierarchy of systems as a system of systems. Most systems have interconnects and interplay with its subsystems. Let's take an example. I think I can explain that it's always a mix of ingredients. Today, if you look at large, complex industrial assets that are out in the field, you'll definitely find that there's a significant number of vendors or suppliers that contributed components to it. If you take the example of an aircraft, right, a Boeing aircraft or an Airbus aircraft, your jet engine probably is coming from Rolls-Royce or Pratt & Whitney or GE. Your frame and the body of the aircraft, like the A380 is built by Airbus, but with multiple suppliers contributing subsystems to it. So when you look at the efficacy or the operating model of the aircraft itself and its subsystems, I think the type of data that is collected, it is a classic integration problem, right? And the type of data that you will collect when you're operating the asset would be coming from multiple sources. And the idea is that it is basically a system of systems, and you have to look at it more holistically, and then optimize and have these value dials that help you not just optimize at the subsystem level, but at an aggregated system of systems level. In the case of this aircraft example I was talking about, the A350 was the new aircraft. I still remember spending a lot of time in Toulouse. And the A350, while the engines were coming from GE in some cases, if you look at the speeds and feeds and the data that you get out of the jet engines use, and if the aircraft happens to be flying in say a warm climate of the Middle East, and you have wear and tear on the blades of the jet engine. Now the data about the wear and tear, which is the operational data of the jet engine, is available to the manufacturer of the jet engine. In this case, it happens to be GE, and they can figure out any unusual issues with the blade, and then they can optimize the manufacturing process upstream in their factories to make sure that the next batch of blades are taking corrective action, for example. Now, that same data feed, which is going to GE as a subsystem, is probably not integrated well, has to be, but not integrated well with the overall A350 data feeds that are coming into Airbus. So if you look at from a operator and a service provider standpoint, if you have a company like Emirates flying that aircraft, they happen to be the user of the aircraft and the operator of it. How would they interact with GE, at the same time interact with Airbus to make sure that the data is all very contextualized and correlated, and there is bottom line better operational condition for the aircraft, right? So it is always beneficial to look at a system from a more holistic standpoint. We talked about the edge tier, the platform tier, the enterprise tier in a typical stack. If you look at the modularity of them, you have to start building these things in a certain componentized way, abstracted from some of the infrastructure elements so that they can move around, be it a Kubernetes container or a Docker container. Depending on what apps you're moving where and running it, you need to have that architected in a manner that it is more modular, and then you have very well-defined interfaces from a security standpoint, from a analytics standpoint, from a data handling standpoint, from a storage standpoint. All of that API set of definitions have to be done properly. The third element about keeping it simple, I think complexity definitely drives costs. It's not just costs, it's about things start to unravel at various levels. I still remember one of my first programs that I wrote when I was in Infosys in the 90s. It was a software application called Finacle, a banking software. And I had to write the general purpose report writer module so that it spits out all these massive reports in the bank on a daily basis for total branch automation. I still remember the code base was so complex and convoluted that today it became a significant black box, and nobody would go in to try and kind of undo or unwind the noodles or the spaghetti that was inside the box. So making sure that the artifacts in both system software, in application level software that is built, is well documented and is simplistic. Simplification actually has many advantages, but the same KISS philosophy applies. Interoperability, I think that is the key. In today's generation of technologies, you will find a lot of innovators coming up with technology solutions at various layers of the stack. If they are not interoperable and they don't work well with each other, then it makes the job of the end user more difficult. I think from many years ago, I think if you look at the enterprise applications world, the ERP world, a lot of challenges were there in terms of making things talk to each other. Even today, if you go to the medical hospital and you look at the ICU and you look at all of these diagnostic machines around the patient, the connectors that are connecting one set of machines to the other are very proprietary and are difficult to keep data flow going between subsystems. Those have become quite a lot of impediments. So the industry itself overall has realized that interoperability is key, and a customer satisfaction cannot be achieved if you have very contained, constrained systems. Another example would be, let's take any energy efficient plant that is manufacturing an industrial product. Let's take Johnson and Johnson or any of these customers. They have Schneider equipment for power management, they have ABB equipment, they have GE equipment. Now, all three of these series of products communicate to their respective industrial IoT platform. In terms of ABB, it goes to Ability platform. In terms of EcoStruxure, it goes to EcoStruxure is Schneider's platform, and then you have Predix from GE. Now, as a customer, if you're running the efficacy of the plant, your goal would be to make sure that these systems talk to each other. And whenever you're looking at the operational metrics, the interoperability between these systems will come to bear in terms of information flow. So there's no clearinghouse mechanisms today, but as more and more these cloud native systems are coming to play, I think people are figuring out ways to exchange information more seamlessly and making it easier for enterprises to get value. The next point is about end user experience, right? And the adoption of technology. If we were to build systems that are not user friendly, not easy to use, I think if you look at the enterprise system versus the consumer oriented systems, the consumer oriented systems get large scale adoptions because they're very easy to use, more friendly compared to the enterprise class systems. It is not necessary that enterprise class systems that are more secure, more robust, need to be more unfriendly to the end user world. So I think a direct correlation is there to use and adoption. And if you realize business value and if it's easy to use, then the adoption will scale. So we have to focus on that. In terms of the discovery-led iterative, I talked about the agile ways of working. I think most often when these systems are designed and built, it is not necessary that you know the end state before day one of starting the project. You have a sense of direction, you know where you need to get to, but at the same time, the 10 steps that you need to take to get to that goal is not something which is very well prescribed and laid out in its magnificent glory and details. So you kind of step back and you approve and approach this as a discovery-led process. You take step at a time, and then you kind of build capabilities. I think the challenge in the industrial IoT world is because these two things, the OT world, the operational technology world, and the IT world, they seem to operate at different velocities. I mean, systems, large industrial systems that have a multi-year long life cycle, right, in terms of building it, deploying it, and then maintaining and supporting it. The end of life, in most cases of large industrial machines, that I can still see turbines and large rotor-based equipment sitting for years and decades, right? Versus on the IT side, the software has a different velocity of execution. So bringing the OT-IT world together in terms of figuring out the right combination, the right blend, and actually creating abstraction levels so that if you have an industrial asset which operates at a different frequency and velocity of change, and then you have a software module that sits on a separate gateway in front of the device so that you can iterate more frequently, those kinds of models have to be put in place. Let's not forget about people and process. I think at the end of the day, there is a technician who's going to do, as an example, do service lifecycle management, do maintenance work on an asset that is now smart, connected. So making sure that the way all of this operational and maintenance efficiency use cases that have been deployed impact the service technician and how it changes the workflow and the way a technician will service the equipment is very important. I think the people part is something that usually comes as an afterthought. But if you start following the design thinking approach, you bake in some of the impact to the workflow of the people involved and the processes involved, it results in a better outcome. From a life cycle aspect, I think most often standing up stacks Designing cool technology solutions is easy, but I think operating, running, and managing that environment is where a bulk of the cost as well as the adoption of the technology sits. So it's very important that the designing of the solution has to take into account the operations of the systems. If you look at the various ways of building and the high velocity innovative ideas of building new applications and technologies, I think one has to consider how do you maintain it, what are the tools for operationalizing it, what is the management and operating environment behind it, and how do you enable that aspect of it. So always look at the comprehensive life cycle of a system or a solution. So we'll cover these aspects one more time as a wrapper towards the end after we go through some more specifics. So let's get into some specific use cases. In my mind, asset management is the most popular use case for the very reason that you can get into operational efficacy use cases, maintenance efficiency use cases, but asset management of anything that is a little bit more valuable than $100 in terms of being smart and connected is one of the most popular use cases that have been deployed. In terms of manufacturing is going through a radical transformation these days, and primarily because of the way mass customization is happening, the demand and expectations of the customer and the product that they purchase is also changing. So the manufacturing environment, there's a lot of application of, I'll get into a little detail on the RAMI architecture and Industry 4.0, how it's getting deployed. But the manufacturing world is ripe for transformation. In terms of supply chain, I think with all this high volume data that is coming together, there is a lot of visibility into how things are doing. Just take the example of cold chain management. In that case, you have vaccines getting shipped from the pharmaceutical manufacturers all the way to the consumers. In that, there is a certain set of environmental parameters that need to be monitored and managed as this product is getting shipped across multimodal ways of transport. You have now immense amount of visibility and availability of information. So enhancing supply chains, doing things better is a very popular use case. Fleet management is one of the earlier ones that have been adopted. It's because you need to put smart connected sensor technology, and over cellular or any kind of comms transport layer, you can get the data into the cloud, figure out where your assets are, how they're moving, how well they're moving. I mean, classic use case around Uber and many other fleet management solutions are there. Security and surveillance has to do with mostly image processing, video processing solutions, because the compute and storage at the endpoint, which happens to be a camera, and also the binary large blob kind of storage technologies on the back end, on how you retain these images, how do you process them, how fast you process them, take corrective action. There's a lot of innovation happening in the video processing domain. Worker health and safety has to do with any asset-intensive businesses. You have a technician or a worker in an environment that can be classified hazardous, anything to do with biometrics, anything to do with geofencing, figuring out people don't walk into a certain area. The multiple sensor technologies can enable a better view and visibility on how the worker is doing. So very popular in resources industry, in the mining sector, in the oil and gas sector. Very advanced series of solutions are there. Connected care has to do with how care is provided. I think if you look at all the widgets that you wear on your body itself, you today can collect a ton of data about your health. In fact, once you collect that, how do you contextualize it, correlate it? If you have a hospital visit, in the clinical setting, there's a bunch of medical devices that are collecting data about you. How do you bring all these pieces of information together to give you a dashboard about you as a patient? A significant amount of good work being done in that space. Connected vehicle, of course, the autonomous vehicle technology, simple capabilities around active driver assistance systems, they're pretty popular. I mean, your car is your computer today in terms of the amount of capabilities that are available. Retail, of course, so there's a lot of customer experience. You must have gone to an Amazon Go store to pick up groceries without actually, and having a completely different set of experience in terms of inventory management, in terms of their supply chain management. Also, there's a lot of innovation happening in the retail sector. Retail sector actually has transformed quite a bit over the last few years, and we expect to see a lot more changes happening there. In terms of the infrastructure, if you look at airports, buildings, any kind of infrastructure that has significant energy consumption, significant people flowing through it, there are many sub-use cases in terms of how you could optimize that experience. I still remember going to a building in Tokyo, which had like 35,000 sensors, and the high volume, high velocity data that it was pumping in was, and there was a AI deep learning model created so that it could actually figure out outliers and issues, and then predict failures so that a corrective action can be taken ahead of time. Now, if you look at it in terms of both green buildings, energy efficient buildings, the deployment of these specific smart infrastructure use cases is huge. It actually has a big sustainability aspect to it, and cities as well as operators are putting that into play. And there are many other sub-use cases. And so in the Q&A period, if you have a specific question on a specific use case, do reach out to me. Let's go a little bit more deeper into the asset management use case. Now, you have just a bunch of examples here in terms of the moving assets. Moving assets actually bring in a little bit more complexity in terms of how your edge is defined. And now, there's been a lot of terms used about fog computing, and the edge itself is pretty abstract. It's not really the edge, because the edge is getting closer. Ideally, the three types of what would you want to do at the edge? I mean, you are collecting data, you have a bunch of sensor technologies, you have some transducers, you convert, and you get this high quality data at the edge. Now, if you want to process something and take some decision with it, you may need some compute at the edge, or you may send it to the cloud, provided your latency window is sub 200 millisecond, if that is okay. If you are trying to do anything in the 30 millisecond kind of range of the loop, or RTT, you may want to get it to telco edge, where you have certain compute, storage, and networking capabilities, and you have a mini DC there, and then you actually process it there. So depending on what is your latency requirements and your throughput requirements, it depends on the payload. So payload and frequency will determine what you have at the edge. So in most of these cases, if the simple use case is about tracking and tracing the asset, you just want to know where your asset is. Like if it's a big, large earth moving equipment, and you just want to make sure that it doesn't leave a certain defined area, and you also want to see when the engine is started, when it's shut down, how the engine is performing, some basic parameters that you get out of the engine from the CAN network. That processing is reasonably minimal. So to do that, you may have to create an edge which is not very complex and can communicate with the backend infrastructure on the platform tier. In terms of the fixed assets, now connectivity is not an issue in that case. You may have a traditional MPLS kind of network, or you may have more complex, more high throughput Wi-Fi environments, or any other ways of connecting your asset where the payload doesn't really matter. You can collect a lot of data. So your edge topology and technologies depends on what type of end point you're talking about. In terms of asset management use cases, if you look at the types of use cases you can deploy, the focus, as I said earlier, the strategy is about has to be about making a material impact for the business. So if you're trying to improve operational efficiencies, which is either some sort of good OEE value, or if you were just trying to make sure that the equipment doesn't fail, I need to know how it's doing. So condition monitoring of it and doing some predictive maintenance, that is top of bin for most CXOs, is to make sure that your operational environment saves you significant effort and time, and your asset is always up and running. So one of the popular use cases around maintenance efficiency and operational efficiency. There are definitely more value in terms of energy efficiency. The pump example, in terms of the utility sector, there is a lot of asset intensive aspects in terms of the production, distribution, and consumption of energy. So most of this visibility aspect is key. There is a saying, what you monitor is what you can manage. So the moment you start seeing data and metrics that show you how things are being consumed, I think that helps you manage and control. In networks, in application of these use cases, I think the only aspect is a little bit more complex is when you talk about command aspects. So it's in terms of remote management. If it is just monitoring all the feeds and all the data about how things are doing, that is one aspect. But now if you're taking control and turning some things on or off at the edge, or taking some corrective action, or operationalizing it, then the complete technical architecture around security, around framework of operations, all of that changes. It becomes a little bit more complex. Monitoring is easier compared to monitoring and command and control. These are some of the use cases. I think adoption of these use cases is focused on business value that you can return to the customer. And so operational efficiency is really top of mind for many CXOs. Before I get over this use case, let me also mention one more point, is that what asset management has enabled, it's not the traditional asset management, but sometimes it has enabled the product to service transformation aspects in a different way. I mean, unintended consequences. Suddenly, now that you have visibility to all the consumables that are sitting inside this cleaning machine, and then you can start forecasting demand on the consumables that will be needed in the next month. So I can see many models being built on the customer 360 and the forecasting aspects of business improvement. So net new value add. We started with operations efficiency use case, but slowly drifted into selling more consumables to the customer because you have a better line of sight. You are selling them new offerings, new business solutions, because now you have insight into what you think is going to happen. This is a very simplistic, in the interest of time and making sure that I don't go too deep into technology, I'm going to cover at a very high level a reference architecture for asset management. So as you have the edge tier, you have different management aspects of making sure you're collecting the right data, you have an upload, download handler technologies. So the edge and the capabilities at the edge can vary from very small to very large capabilities. Ideally, the compute, storage, and networking capabilities are getting very effective in terms of price performance value. So more and more of the edge is getting more smarter, more the ability to store more information. Let me give you an example. If you even have a graphics card on one of the edges, small edge nodes, you can virtualize it. You can start creating multiple VMs with graphics in them, and then you can do SIMD type of workloads. You can do a lot more training of the models if you have AI models and not just do the inference. So what you put in the edge and how much money and cost is involved in crafting the edge will also determine what capabilities you have. I think the key aspect is the edge is the entry point and the collection point to all the high volume data that is coming in that you can generate. But eventually, you will have to do good analysis on it. So stream analytics, different types of event processing, the logic associated with it, that is all sitting in a platform tier. Now you can have it also or componentize it and have it sit in multiple elements, log analytics management, the security aspect, the automation aspects. But there are many platforms that now again, you can separate the platforms also as an infrastructure as a service tier of services, or you can add the software as a service tier on top, platform as a service. If you look at many of these platform as a service capabilities, the more you intrinsically start using them, you get tethered to one cloud major or another cloud major. So multi-cloud is the world that we are living in. So the more you start constructing applications and solutions that are end-to-end resident in one platform versus another, you lose the ability to do more heterogeneous answers to the solution. The enterprise side is reasonably clear. It's been existing for a long time. I think you can see the number of enterprise solutions have to realize the value, and the service lifecycle management is a good example of it. But most of the ERP systems is where some of the gravity of the business operations is. So a simplistic view, 3 tiers, more details on many of these use cases are available on the Industrial Internet Consortium's website. I'll give you an example. These are just services available from AWS and Azure. So the any device concept is true. The endpoints can be many, but there are very specific services that AWS offers as well as Azure offers that help you collect all this data. There are agents that you can put on the edge device. You can, once you get, the idea is to get all this data into the cloud where you can run either Azure time series insights in terms of Microsoft cloud, or if it is AWS IoT analytics in terms of AWS. The idea is the multi-cloud world is here. Now, if you start using services, very complex, more modern services available in the cloud world, and kind of integrate your app both at the edge tier and the platform tier to use these services, then you're kind of creating some sort of dependency between the platform offering and the stack that you have built. So ideally, in a multi-cloud world, you want to build solutions that can operate across multiple clouds. This is just an example. So the options are many: private cloud, public cloud, hybrid scenarios, edge cloud, telco cloud. So it's the number of offerings and the number of options we have is many. That is where the world is headed to, is a multi-cloud world. In terms of the virtualization technologies, I just wanted to, I love this vision that VMware has painted. It's an old, it's a very well-defined old technology element, and the strategy, the vision has been in play for many years. Any cloud, any application, any device. I think if you look at, as I mentioned earlier, you have the private cloud, you have the public cloud, the edge cloud, as well as the telco cloud. Depending on the latency that you need, depending on the throughput that you need, and the type of compute, network, and storage capabilities, you have a wide variety of infrastructure options. And at the same time, with this wide variety of options comes the wide variety of tools that you need to manage and operate these environments. In terms of the app, again, you can build cloud native apps, traditional apps. Again, there's old archaic apps as well, but these apps can be deployed in any devices. And so the any device to any app to any cloud, that approach is real. That is where the world is headed to. So ideally, operating and becoming a master of multi-cloud environment is where you would get the most success. So if you're getting into technology areas, learn and read and become the master of the multi-cloud. In terms of the data, again, we talked about high volume, high velocity data coming from the edge. There is significant amount of work involved. I have seen that with many customers where once a remote services platform is put into play and has been built, and now you have this spigot from where you have data coming through, what do you do with it? To build models, to create the analytics and the insights, you have to go through contextualization and correlation of data. If it's asset data about operational data, how do you bring it together? To bring it together, you have to have some ETL that you will have to do. You have to create these data pipelines. All of this is very tedious, time-consuming data science work. And then you visualize it using Power BI or QuickSight or any of these tools. But to do that, this EDO2 kind of enterprise data operations kind of technologies, data foundries that are coming together. A good example is one of InfoWorks. Those can help automate and help you design once and deploy everywhere kind of solutions. So if you look at it, any data, any application available to you anytime is also the next mantra. In terms of the ecosystem play, you need interoperable on-demand kind of solutions. So what that means is there is a lot of consortium work or a lot of industry work that needs to happen in terms of making things come together. IIC has done a great job. Dr. Soli, who's also, by the way, an MIT alumni. I won't tell you which part of the 70s he graduated, but the IIC reference architecture helps you bring these multiple solutions together. Same thing is happening with Dr. Henning Bantheim and his team in Platform Industry 4.0. The WEF team also over here in Presidio have a C4IR center, which is trying to do the same thing. Digital Twin is a new consortium around modeling. So all of these industry bodies or forums and organizations are trying to get people to work well collaboratively together to create these interoperable systems. Because as I mentioned earlier, there is no one vertically integrated stack. It has to be multiple components coming together to make a solution. So top of mind for an end user, support for multi-cloud, hybrid infrastructure. So basic levels of abstraction, automation, and cost. Of course, you don't want to go into the cloud and have a significant amount of cost. And I've seen many customers getting surprised and getting sticker shock, saying, I collected all this data. In the end of the month, you get X amount of dollars for a bill. So you try to optimize what you collect, how you process, where do you store, what type of storage you use. So in this entire journey, I think the support for multi-cloud is very important. Pervasive security end-to-end, very important. A single pane of glass in terms of operations, very, very important, because as you have these multi-cloud heterogeneous mix of ingredients, you cannot have multiple tools to manage and operate them. And also, of course, you also think about deploy and operate, not just the design and build aspects. One more time, the summary: systems of systems, keep it modular, have very well-defined abstract them, have well-defined interfaces. Interoperability is the key. Focus on end-user experience. And of course, people and processes are as important as technology. Before I get into the Q&A space, I want to make sure, Naomi, we have enough time for the Q&A. I would make one more comment is, at the end of the day, if you focus on good end user experience and realizing a solid business outcome, be it top line or bottom line for the customer, then these projects can be very successful. With that, Naomi, the floor is yours.
Thank you. And thank you so much for this excellent talk. It's been really fascinating. One thing I wanted to mention really briefly, first of all, if any of our viewers have questions, again, you can enter them on the right side of the YouTube window to the right of the video. I did want to mention, you spoke quite a bit about agility. We did actually have Stephen Eppinger, who's a professor at MIT Sloan and one of the faculty co-directors of the SDM program. He delivered a webinar last year called 10 Agile Ideas Worth Sharing, which is about how people can apply Agile principles in any industry. So if any of our viewers found that interesting, I recommend they check that out. I also, it looks like we already have a question, so I'll start with that. From Mercedes Delgado, asking, what type of occupational skills are needed for scaling up IoT services?
So occupational skills is if you are, so the people side, if you look at everything is trying to solve a business problem. So if it has to do with service lifecycle management, if you are an operations guru, if you want to understand OR kind of approaches, statistical and OR kind of approaches, that kind of skill set is very valuable from a business standpoint. From a technology standpoint, of course, compute network storage and the entire multi-cloud kind of technologies are very relevant. You can apply them in terms of an IT and an engineer trying to solve and build a reference architecture and a stack. So both from a computer science expertise in terms of building out the solution set is valuable. But, the interesting part is it also brings in a lot of knowledge of the physics and the OT, which is not something that we think about too much, saying, oh, IoT is a computer technology kind of oriented learning. But if you look at the OT skills, the skills about the physics, the domain knowledge If it's about an industrial asset, you have to maintain it. The algorithm is not something that happens by magic and somebody programs in a computer. I mean, there is domain knowledge, there is physics that needs to be incorporated into it. So that knowledge is also very valuable. So broad set of capabilities. If you want to make a transformative impact, this is not constraining. You don't have to be a computer engineer. You don't have to be a mechanical engineer. You don't have to. If you have those skills, you can play an effective role in any one of these areas. At the same time, there's also a people transformation process. So if you can help transform an organization on how people work and how they apply their skills, that is also very useful.
Great. We have another question from Bengalia4, who says, I work for an industrial manufacturer. We're interested in connecting directly to shop floor equipment via PLC, etc. What method would you recommend?
So in terms of the PLC SCADA world of yesterday, I don't think there is any kind of challenge because there are many protocol conversion methods available. If you have let's take an automation plant, and if you have a lot of machines that have to be now connected, multiple adapters and converters are available to enable this integration. So it depends on the types of machines though, but that is not a significant problem. Protocol conversion is commonplace at the edge, from OPC UA to MQTT. You can do, from a software standpoint, you can do anything that you want in terms of conversion. It's mostly about if there are physical interconnects that need to be converted, there is a certain set of specs that are out there. If you visit Industrial Internet Consortium and look at some of the smart manufacturing solutions and factory automation solutions, you can see some of them. It's in the testbed section of the IIC. Hopefully that answers your question.
Thanks for that answer. I had a question while I was listening to the lecture. You talked quite a bit about interoperability and the importance of having various technologies that can interface well, because every single connection point can be a place where things get more complicated. But I was curious about the tension between that need for interoperability and the need for privacy and security of information. So for instance, you talked about connected care in the healthcare industry, and the importance in tension with that of patient privacy. Do you have any thoughts about that or any experiences that relate to that?
Yeah, absolutely. In fact, anonymizing information is reasonably easy. But at the what tier, so especially in healthcare, I mean, there are many regulatory HIPAA kind of regulations that prevent access to private information. And it is well organized. I mean, the only people who have the right to see that information can see it. So anonymization is one way. But in terms of some of these asset management scenarios that we have deployed in many hospitals, those are anyway encrypted containers. The information itself, the payload is not something that reveals the privacy aspects. It's more about the asset information. It's not about the patient. But whenever you contextualize and correlate all these pieces of information in the cloud, and you have usernames and all that, there are certain control mechanisms in place by most hospitals to make sure private information doesn't go public. So you can anonymize it. At the same time, your storage, your processing methods, and who has access, this whole authorization and access approaches itself takes on a different level and meaning. It is not the same as monitoring how an industrial machine is working. Patient information is private, and there are many ways of protecting it. In terms of security, of course, there are many methods that are applied in terms of how information is stored and processed, how people can gain access to it. And there are varying levels of it that people have deployed, depending on the use case. It's a broad topic, a day-long conversation we can have on security, but privacy, of course, on healthcare is paramount, and people have been cognizant from day one in terms of implementing them.
Thank you so much. I think we have just about hit time. So once again, thank you, Jayraj, for your wonderful lecture. It looks like you do have your email address up in that last slide if people would like to contact you with further questions. Yes, and thanks to all of our viewers online for attending the webinar. The presentation recording will be available permanently on YouTube after this session. And we welcome everybody to join us in April for our next webinar with Douglas Haig, the Executive Director of the School of Data Science at the University of North Carolina, Charlotte.
Excellent. Have a good spring break, guys. Thank you very much.
Yes, thank you. On behalf of the System Design and Management Program, thank you for joining us.
Thank you very much.